Our next question, I do understand the gradient question. Remember to make 100% sure about the use regarding the distance, 100 and 500. The next question, I've got a couple of questions, kg and Cabello. Now, both of them asked me vertical exaggeration. Now, vertical exaggeration is, we usually ask this question, the examiner usually asks this question once after a cross-section. Now, a cross-section, we've looked at a cross-section, it's a side profile of a landform, or from point 1 to point B. Now, I'm just going to give you a simple example of a cross-section. If you quickly look on this map, sorry, I'm going to do it so roughly. Now, we have changed the way we've asked cross-sections in matric papers because cross-sections are so time-consuming. That's the bloody problem. It takes so long because the contour lines on some places on the maps are very close to one to each other, and it's extremely difficult to determine it at its time. So most of the time, they will ask you to go and draw a freehand cross-section. I'm going to give you a simple example, and then I'm going to explain vertical exaggeration to you. Now, for instance, let's say they ask me to draw a cross-section from this spot height, and there is contour lines. Okay. So this spot height is 100. Let's assume this is a 1 to 50,000 map. Okay. That spot height is 100. What do we work? Contour interval is always 20 meters on the topographical map. Contour line will be 80. This one will be 60. This one will be 40. Let's say 20. Let's assume this one is 20 as well. This contour line going to be, it's going to be at center, sea level. So let's say to draw a cross section from spot height 100 to, yeah, I just need to fill in another. So another contour line. So let's just quickly have a look at it. Let's assume they ask me to go and construct a freehand cross section from spot height 100 all the way to 60. Okay. So that horizontal scale. Okay. Why is it my horizontal scale? So basically my horizontal axis, right? Because when you look at your cross section, this is where you get the information from. So if you go back, if you look at the cross section, it consists of the y-axis and the x-axis. Now, as you can see, this is your horizontal scale. Now, where did I get my horizontal scale from? I got it from my topographical map. So the horizontal scale is 1 to 50,000. Now, grade 12 is very important. The examiner, that's me, or that's your teacher, geography teacher. He will always provide you with the vertical scale. So he will tell you the vertical scale that 1 centimeter is going to represent 20 meters. 1 centimeter might represent 40 meters. 1 centimeter might represent 10 meters. Okay. So you need to determine, once they ask you the cross section, you need to determine where was this cross section asked. Was it in an orthophoto or was it on a topographical map? Okay. The examiner, your teacher, will provide you with the vertical scale. So in this case, let's go to a vertical scale. I will tell you the vertical scale is 1 centimeter represents 20 meters. Okay. Now to construct a cross section, you always go to your lowest contour line. In this case, it's 0. Okay. So you've got the 0 over there. So for every centimeters, we increase with 20 meters. So there's 20. Just want to write this a little bit on the side. Oops, sorry. We'll rewrite this. Yeah. Vertical scale is 1 centimeter represents 20 meters. So our next centimeters will represent 40. Our next centimeter will represent 60, 80. What's our highest altitude? Is 100. Okay. Now, as you can see, the horizontal scale is the map that we use. In this case, like I've mentioned, the topographical map. Okay. Now, I'm just going to use this roughly a freehand cross section. There is the one we just dotted down line there according to our, there's the 80 line, it's situated over there, 60 all the way down there, 40 quite steep over there, 20 situated over there. Okay, it's not entirely corrected. Let me just correct it quickly. I got lost there where the 80 is. Okay, 80, there's the line over there, 60 over there, 40 down there, 20. Okay, 0 in line with our 0 contour line, 20 in line with our 20 contour line, 40 in line with our 40 contour line, and eventually 60. Okay, immediately what shape can we see over here? The valley shape. Okay, this is a freehand cross section. Now, like I've said, that you tend to ask the freehand cross section where you just need to go and determine the shape. But coming with where this vertical exaggeration comes in. So basically, what did we do over here? We want to know, we've been given a horizontal scale. The examiner has given us a vertical scale. We want to know this landform. How many times was it exaggerated? Okay. How many times was it made bigger? Okay. Very simple, once again, definition. And if you look at the formula of vertical exaggeration, it follows as vertical exaggeration equals vertical scale over horizontal scale. Let's just write it out, because for you making notes at home. Hey. Okay. So that's the formula for vertical exaggeration. Now I'm going to show you how bloody easy this actually is. Okay. What did I mention? If you look at your formula, first thing you need to know, the vertical scale will always will be given to you by your teacher or your examiner. The only thing that you need to do, that's been given to you in the question. I'm going to give you an example now. The horizontal scale is only one of two things. Okay, only one of two things. 1 to 10,000 or 1 to 50,000. Okay. Why only 1 to 10,000 and why only 1 to 50,000? Because this is the two maps that we use. They can either ask you to go and calculate the vertical exaggeration on the orthophoto, or they can go and ask you to go and calculate the vertical exaggeration on the topographical map. But the only thing that you need to determine that. Remember, the vertical scale is going to be given to you in the question. So let me just give you an example of the question that's going to be asked. The question is going to be asked, calculate the vertical exaggeration for the cross section. Let's assume there was a cross section asked. Cross section on the topographical map. And then, as I said, when we look at the vertical scale, who will give it to you? I will give it to you. Your examiner will give it to you. Use a vertical scale of 1 centimeters represents 20 meters. Now pay attention, great class. What has just happened over here? Here's your vertical scale. Okay. Where's your horizontal scale? There you go. So for your formula, everything has been given to you right there. You need to determine, read your question carefully. Is it the topographical map or photo map? In this case, it's the topographical map. So let's continue. Just want to clean my board over here. And then we can do our question. So the question is vertical exaggeration of the cross section and use a vertical scale of 1 centimeters represents 20 meters. Vertical exaggeration equals our horizontal scale. The vertical scale is 1 centimeter represents 20 meters. And what's our horizontal scale? Because we map, it's going to be 1 to 50,000. So basically our formula is complete. But the next step, like now what do you need to do is, our vertical scale is being presented, we need to convert it to what now? To centimeters. If you look at our formula, what does that 1 to 50,000 means? It means that 1 centimeters represents 50,000 centimeters. If you look at our vertical scale, it represents to 20 meters. So what do we need? We need to convert our 20 meters to centimeters. That's simple. How many centimeters is there in a meter? Okay, work that out. Correct. How many centimeters is there in 10 meters? How many centimeters? If there's 100 centimeters in 1 meter, how many centimeters is going to be in 10 meters? 1,000. How many centimeters is going to be in 20 meters? 1 to 2,000. Remember, our horizontal scale stays exactly the same. What do we 2,000 times 50,000 to 1. What do we say? 50,000 divided by 2,000. Yeah, I'll calculate it quickly out. 50,000 divided by 2,000 equals 25 times. Okay, and that's how simple it is. 3 common mistakes. Two common mistakes. You do not look where the cross section on which map they've asked the question, usually on the orthophoto or on the topographical map. Because it was on the orthophoto, what will happen? It will change to 10,000. Okay, and then you need to convert your meters back to centimeters, like I just did over there. If you go and have a look at your 20 meters, 1 centimeter represents 20 meters. Matter of fact is, remember, our horizontal scale has been represented 1 to 50,000. It means it's 1 centimeter represents 50. So how many centimeters there in 20 meters? 2,000. 1 times 50,000 to 1 is 50,000 equals 25 times. Okay, that is vertical exaggeration. Now, what have we done so far in this last hour? Basically, our Mapwork calculations. Okay, thank you, Gift, Cabello, KG. All of you basically asked the same questions regarding these calculations. Hopefully, you can apply them simply, but most importantly, grade 12, go and read your question. Determine which map they ask you to go and do the calculation. And very importantly, remember your formulas. And don't rock up at the exam at the venue without a protractor. As you can see, it's quite important. You can't, for instance, do magnetic bearing if you don't have a protractor. Make sure you have all of these stationary items. Okay. Now, before I'm going to continue with GIS and the questions that we received today, I want to continue looking at the map. And many of the questions regarding GIS are focused on the map that you will receive. And they're going to ask you specifications of GIS. Now, if we look at GIS, on the topic of GIS, I want you to remember this. If you know your concept, the definitions of everything that's being asked in the GIS section, right, you will get more than 70%. Okay. If you look at GIS, it's such a wonderful program that we use, and I will explain it to you in a couple of minutes' time. But unfortunately, all our schools are not tech savvy enough to be able to do GIS with their learners. Okay. Unfortunately, many schools only have the textbooks to give them examples of GIS. But it's such a tech-savvy way to gain information. I'll explain it to you in a couple of minutes. So when we're going to start with section, I want you to pay attention especially to your concept, okay, because they are vitally important. And you need to take this context, the concepts that you've learned and definitions that you've learned, and apply them to the map that they're going to ask it from. And I want to concentrate, for instance, on these different aspects, okay? Now, GIS revolves all about information, okay? And you need to be able to identify these types of information on a map. Now, everything that we've learned, I want to show you just how much everything one another. First of all, let's just start with climate, for example. Now, first of all, we need to recognize what type of climate are we going to experience over here. We're going to experience, it's a coastal area, so they experience different types of climates that continental climate. Morphology taking place over here because we have the Buffalo River. This is the lower course of the river, okay, as you can see. Now, as you can see, like we discussed a couple of weeks ago, 2 weeks ago, when we looked at Central Business District, outlaying over there, okay. There is rural urban fringe. Okay, as you can see, there's low income small plot sizes. Then we have high income residential areas. You look at the property bigger, and you can see it's ocean views. Now, obviously, if we look at the rich people, where they use this Clifton down in Cape Town, absolutely marvelous because you've got these sea views, 380 degrees, absolutely beautiful. Okay, and we can look at our industrial areas, your light industries and your heavy industries. So many questions regarding GIS might come from a map like this. They might ask you, why is the light industry situated over there? Why is the high income residential? In information, what are we going to use to gain this information? Okay, this is just some examples. Now, if you look at the airport, we discussed it. It might be on a rural urban fringe, but what else can we say? They might create buffer zones, which I will explain to you in a couple of minutes. As you can see, the sewage of East London because of the pollution, the smell, and once again, we're coming back to settlement. East London, what type? It might be a break of bulk town. Now, if you look at East London, many car manufacturers, VW, okay. So, for instance, they get locally built over there. What happens? They're getting shipped to different continents from East London. Now we're touching sides of our next topic that we're going to discuss, and we're looking at economic activities in South Africa. Okay, see this Benz, what is it? It's a German factory car. Okay, why is it being built in South Africa? Cheaper to build over here because our labor costs are less. Okay, so what this might be? It might be a break of bulk town. Things might come in one form of transport, and it may leave in another form of transport. Okay. If we look at the industrial area over here, they're close to the river. They might need the water for their type of activities. They are close to the industrial area to basically reduce their cost on manufacture it, right? To ship it overseas, for instance, the cars from Johannesburg. Let's assume we did. What's going to happen? Then we have travel all the way, put them on trucks. It's going to be more expensive. Load them onto a freight to different continents. So it's a break of bulk towns, much cheaper. Okay. Now, if you look at the outskirts, once again, we can look at the golf course for recreation areas. They might ask you, for instance, as you can see, that we're going to learn about a little bit later, about GIS. Why is it buffered? We've learned about this as well. Green belts are very important. Okay. It creates air quality. Okay. We can even go a little bit further, going back to local. What does it do? It reduces urban heat islands. Okay, as you can see, there's so much industrial activity taking place on this map of East London. If you just quickly have a look at our next map, and our examples of purchasing contour lines as well as boundaries visible on maps. Now, this is very important to read. But we use natural features such as rivers, railway lines, okay, as you can see, to protect certain areas, to demark. For instance, if you look at this wetland projects here in South Africa, it's no example, it's in Lucia, a buffer zone that's being created over there around Greater St. Lucia wetlands. As you can see, there's the railway line between Mozambique and South Africa. But as you can see, these access to the wetlands of St. Lucia. Here, a river is being used as a provincial boundary to separate. For example, as the Limpopo River in Limpopo province, it separates Zimbabwe. We had buffer zones around this area to protect these areas as well. Okay, very good example. That's another example in South Africa. The N1 creates buffer zones between many township areas and residential areas state development. Okay, for instance, between Soweto and South Africa. I'm not too familiar with Cape Town, but it's Mitchell's Plain and the residential suburbs. Okay, if we quickly go to our next map. Okay, that was our final map. Right, let's just quickly, before we're going to start with GIS, your legs, grab a glass of water, coffee, whatever, and let's get straight into it.